Here, press here. Did you see where I pressed it? Okay, here. This is the syllabus. This is the syllabus questionnaire, right? Okay, you click on here, and you have to put your tag ID number, your last name, first name, phone number, best time to contact, like that, and then I have read the entire syllabus. It should be yours, right? All right, you go on answering this. Whatever is on the syllabus, and whatever we described in the class today, should be able to answer these questions. All right, go home and answer these questions. All right, then I know you have done your part. All right. So there won't be any misunderstanding about what is required here. Right. All right. So that's one thing. Course calendar here. See that we starting on November 30th, discuss syllabus, review or whatever for the organic chemistry. Okay, we're going to start with organic chemistry. We'll discuss it in a minute. And syllabus questionnaire is due that day, Friday. Okay? All right. Now I'm going to do the introduction to OWL quickly. Then I will start. Okay? Okay. I want you to remember this. This OWL is independent program that comes with the book. Okay? Sometimes tech web page is down. Still, you can go and do the OWL. Yes.
If we have can we use the 4th edition of the textbook, or does it have to be the 5th current one?
I don't mind, if you're doing 4th edition, right? But I mean, it's almost same, but there may be some revisions, all right? So the content is the same, right? Now you can buy OWL separately, okay? OWL could be bought separately. This web page is Cengage, CENGAGE.com, OWL, okay? This is what I typed. Okay, it goes there. Now, this chemistry is called GOB Allied Health course. Most of now you can buy access code here, or then you can register. Then you log in with your registered login name. So I have a password. So after you register, then you go to take the book. Did you see what I did? I log in, right? Pick the login. There were 3 choices: buy access code, register, login. I did the login because I have done these 2 parts. If you haven't done those two sections above, you cannot log in, right? You don't have a password. Okay, I picked the book. Book is the Stroker, okay? General Organic Biological Chemistry, 5th edition. How many of you taken 120 before? Okay, that's the chapter up until about 11. We try to introduce you to concept in beginning of the chapters. When you come here, then you have to pick the school after you pick the book. This is the one, Louisiana Tech University, right? Now I log in, right? So now I go to this. That's my name. Okay. Now I log in. Okay. Get it? Yeah? So after you log in and register and log in, your name will appear here. For example, I think when you're logging in, when you're logging in, you will be asked to pick a course. You need to pick this one. You see that? That's what. Okay, let me look at it as a student now. I go to the student window. That's how you would see introduction to organic biochemistry. All right. So to see the assignment, you have to click on assignment list, right? Here. All right. Now it shows chapter. There are introduction to our parts here, and then you, if you had an ebook, you can look at the ebook here. And let me make it a little bigger. Now, up until now, December 20th, okay? You have chapter 13, because the first test is going to be on chapter 12 and 13. First test is going to be on chapter 11 and 12 and 13. Second test is going to be 14, 15, 16. Third test is going to be on 17, 18, 19. Fourth test is going to be 20. There on the, all right. So I have to remember all these things because I've been doing this a long time. Now, other way to look at this assignment is, if you're not clear about what is need to be done on my syllabus, I had our CM. Our CM means, OWL stand for online web learning. OWL. CM means concept mastery. So where you find all this on the OWL, okay. To see that, go to all assignments, all right? You go to all assignments, all right? That's what you use. I recommend go to all assignments and start doing introduction to OWL. Then you need to be starting this one right now, okay? All right. In the calendar, I have given you the date that you should be following, finishing up OWL. But I'm not going to micromanage. What I did was, all these OWL sections are due on December 20th. It's on the calendar. For example, if you want to do this, let's pick up. You go to bonding characteristic of carbon atoms. You click on that. Okay. All mastery, MAS is mastery, representing organic compounds. Okay. If I click on that, they give you 3 questions. All right. This is the ball and stick model. This is the space filling model. I'm going to show you these things. Read these. This is information. See that text here is the information. You're not supposed to do anything, but you have to read this, right? Then you go and start doing this. Okay, example here. Match the condensed structural formula on the left with the Lewis diagram on the right. All right. These are condensed formulas. Chemical formula is only elements and the subscripts, okay, number of atoms, okay, that's the chemical formula. Condensed formula gives little more information. That's the carbon chain, okay. Now this is kind of 4 carbon atoms attached to each other in a chain, and an OH group is replacing a hydrogen atom. We're going to talk about this later. So match. This one is this. You see that? And that one is this, right? And that one is this, all right? And that one is this. These are structural formulas. This is condensed formulas, all right? So in a way, doing this, you understand what is a structural formula, what is a condensed formula, right? So that's the idea. let's finish this off, then I'm going to let you go do yourself. Okay, this will be number 4, and this will be number 2, and this will be number 3, and that's number 1. Okay. Good thing about this is, if you even make a mistake, you can redo it, right? It will give you another problem, right? So, in a way, I like this because you have got to do something. Education is not a consumer product. You know, we cannot finish it. We both are working on it, right? It's not we are not selling a product, and you are also a part of the manufacturer, right? So you create your own learning. You understand what I'm saying? You cannot call me, deliver me, you know. Here is the 121, right? Okay, all right. If you have any question, I will be willing to sit down with you and show you what to do and things like that, all right? Okay. You see that chapter outline? We're dealing with matter, all right? Matter, chemical compounds. Specifically, we are dealing with all matter. Then it could be roughly divided into 2 groups. Organic compounds and inorganic compounds. Okay. If you look at that, man, there are many organic compounds. There are less inorganic compounds. How do you define an inorganic compound and an organic compound? What makes something organic, something inorganic? Of course, rocks are natural, right? Right. Naturally occurring carbon-containing compounds, right? Therefore, carbon dioxide is organic? No. Carbon dioxide coming from carbonates, right? Organic is kind of a more like organic compounds have a relation to living things, right? Most of the organic compound we find on Earth is produced through the biological activity like petroleum, all right? So plant-based, you know, a lot of things. Organic chemistry will be dealing with organic molecules. Inorganic chemistry will be mainly dealing with inorganic material. Then biochemistry will be dealing with biochemicals, right? So biochemicals are produced in living systems. Therefore, biochemistry is chemistry of living things. All right. Okay, we're going to look at this. Circle the correct compound type, ionic or covalent. Now, this thing, ionic versus covalent, we did it in 120. What is the definition of ionic and covalent? Covalent is sharing electron, bonds are drawn with a line, right? Ionic is attraction between ions like sodium chloride. There's there's a attraction, but there's no direction to bond. It could be anywhere, you know. So that's the compound made up of ions. Molecules, a collection of atoms connected through covalent bonds are called covalent molecules, compounds. This one is, what kind of a molecule is this? Or compound? Compound is a substance made out of more than one element, right? Compound. Okay. How do you know this one is, what do you pick here? Ionic or covalent? Covalent. Why is that? In 120 chemistry, we understood that non-metals and non-metals, right? forms covalent bonds. What are nonmetals? In the periodic table, that line passing through boron, silicon, then down germanium, arsenic, and arsenic, antimony, like a step ladder, right? On that side, you have on the right side, you have the nonmetals, and the left side, you have the metals, right? In here, nitrogen and bromine are on the nonmetal side, therefore two nonmetals will bond covalently, therefore they are going to be covalent compound. Now that one is sodium chloride. Same argument we apply. Metal and non-metal forms ionic. Metals gain lose electrons, non-metals gain electrons, right? To achieve the noble gas electron configuration. We didn't done that in chapter 120, chemistry 120, because they wanted to achieve inert gas electron configurations, right? Okay. Now that one is definitely not inorganic. Why? This one has carbon and hydrogen and oxygen also. Organic compounds have those characteristics: carbon, hydrogen, oxygen, nitrogen, right? All these things. And inorganic has oxides, metals, right? Mainly ionic compounds. Inorganic compounds are polyatomic ions and all that, calcium carbonate, sodium sulfate, right? Now when you look at this one, definitely this is what? There's no carbon, right? So that itself will rule out this. Besides that, there are ions. How many of you heard about NH4 plus ammonium ion? Do you remember that? Ammonium ion. And what is the NH3 negative? Nitrate ion, ammonium nitrate, right? All right, this is kind of a review of your 120 chemistry. Okay. We don't want to go back and redo all this stuff. I'm trying to recall whatever necessary and do it. In chemistry 120, what you did was atomic structure, and then you learn about the shells, right? Then we went to the quantum theory, right? Atomic orbitals, remember? Valence shell, and all these things. Now, this is one way to, this is carbon, the element to carbon. For the atoms and ions below, there could be ion. Circle the correct ground state valence electronic configuration of the carbon in co-format. Now, you have to understand these things. What is valence electron configuration? And what is the co-format, right? The valence electron configuration is the orbitals of the last shell, right? Where the electrons are added. Remember that? So valence shell for carbon is second shell. All right. So if you look at this, it has to be S block for 2s, 2. There are 2 elements, and you go here. This is 2p, right? 6 places, because p orbitals there are 3 p orbitals. Each one can take 2 electrons, right? 2 elements. Okay, that's 2p2, 2p1 boron. You understood how to write the valence electron configuration, didn't you? Okay. So now this one for carbon, that's the valence electron core format is, you write down the valence shell electron configuration like 2s2, 2p2, and show the core. What do you mean by the core? Core is the inner shells, right? Inside. That would be helium, right? So core format is like, you abbreviate it as a helium, right? And normally the carbon electronic configuration is going to be like this. In the core format, carbon is going to be helium, 2s2, 2p2. Now this is the electronic configuration of carbon in core format, and box format, box diagram. Box diagram is, you write helium here, and you expand this to boxes. Now remember, there are 3 boxes for orbitals, atomic orbital. This is called 2p2, this is called 2s2, and this is 2. Then we follow Hund's rule. Remember? Guys, remembering any of these? Anyway, I'm revising. We don't. Okay, if you look at that one, oxygen and bromine are on the non-metal side, therefore 2 non-metals will bond covalently, therefore they are going to be covalent compound. Now that one is sodium chloride. Same argument we apply. Metal and non-metal forms ionic. Metals gain lose electrons, non-metals gain electrons, right? To achieve the noble gas electron configuration. We didn't done that in chapter 120, chemistry 120, because they wanted to achieve inert gas electron configurations, right? Okay. Now that one is definitely not inorganic. Why? This one has carbon and hydrogen and oxygen also. Organic compounds have those characteristics: carbon, hydrogen, oxygen, nitrogen, right? All these things. And inorganic has oxides, metals, right? Mainly ionic compounds. Inorganic compounds are polyatomic ions and all that, calcium carbonate, sodium sulfate, right? Now when you look at this one, definitely this is what? There's no carbon, right? So that itself will rule out this. Besides that, there are ions. How many of you heard about NH4 plus ammonium ion? Do you remember that? Ammonium ion. And what is the NH3 negative? Nitrate ion, ammonium nitrate, right? All right, this is kind of a review of your 120 chemistry. Okay. We don't want to go back and redo all this stuff. I'm trying to recall whatever necessary and do it. In chemistry 120, what you did was atomic structure, and then you learn about the shells, right? Then we went to the quantum theory, right? Atomic orbitals, remember? Valence shell, and all these things. Now, this is one way to this carbon. Okay, which one is the, for the atoms and ions, we will circle the correct ground state electronic configuration of carbon. That is the carbon, okay? Now, this is a kind of a box formatting written down. Do you understand? This is written down in a form. There are 3, P, X, P, Y, P, C. There are 3 atomic orbitals. on the p shell. This is going to be 1, 1, 0, right? Okay, so which one is making sense now? Okay, there's a problem. There's no co in here. You understand what I'm saying? Co has to be. This is the wrong co anyway. And anyway, this is 3 valence shell is not third shell for carbon. You understand that? And then carbon is here, the helium, right? And that one is exactly what we came up with ourselves, right? Okay. We focus on carbon because we are going to do the carbon, right? Carbon chemistry. All right. Carbon makes 4 bonds. According to this, there's only 2 unpaired electrons. Carbon should make 4 bonds, 2 bonds. What happens is, when you're making bond, this electron is kicked up here. What happens is, when it's making a bond, this electron goes to there, then there are 4 unpaired electrons. That is excited state. When you're trying to make a bond, you change yourself, right? Okay, here. That one is ground state, right? If the excited state could have been this, right? No, it's wrong. There are more electrons there. How many valence electrons carbon has? 4. That one has 5. Anyway, you got the idea. All right. Carbon makes 4 bonds. All right? And wherever in a structure you're looking at, look for 4 bonds for carbon, 2 bonds for oxygen, right? 3 bonds for nitrogen, because unpaired electrons. All right. Now we also drew Lewis structures in 120, chemistry 120. How many of you remember Lewis structures we talked about? Now each main group, the main groups are the ones which are tall columns in here. How many of them are there? 8. 1, 2, 3, 4, 5, 6, 7, 8. All right? These are transition elements, and these electrons go inside after inside the valence shell. Therefore, they are not the valence shell normally. All right? Anyway, to explain the bonding, we can draw a Lewis structure or Lewis symbol for an element, right? For example, which one is the correct Lewis symbol for nitrogen?
First one.
How many valence electrons in nitrogen? 5. How do you know? 1, 2, 3, 4, 5 in the periodic table, from N to the where the element is, right? There are 5. So therefore, this has 5. This has 6. Okay. So and sometimes you follow Hund's rule here. You put 1, 2, 3, 1, 2, 3, 4, and pair up. All right. So there are 3 unpaired electrons. Therefore, how many bonds are formed by nitrogen? 3. I mean, you went for the right there. There are 3. Okay, that's for nitrogen, right? But nitrogen has a lone pair, right? So, how many of you got that now? What would be the Lewis symbol for oxygen? The X could be nitrogen going to be this. What would be the oxygen? 6 electrons. 1, 2, 3, 4, 5, 6. How many bonds are formed by oxygen? 2 bonds. So the Lewis structure of carbon has 4. So therefore, this Lewis structure, was really handy to tell somebody that carbon makes how many bonds? 4. Okay. What is the Lewis structure of carbon? I jumped the gun anyway. Yeah. There had to be 4 electrons. Which one is that? Last one. Okay. You circle, right? Okay. Now we also need to know about structures of organic compound, right? Structures of organic compound. One of them is Lewis structures. Okay. Now, how many of you know Lewis structure of water is this? Okay, this. Do you remember that? How many of you remember this? Lewis structure. Okay. There are 4 pairs of electrons, lone pairs and bonding electron pairs, right? Okay. There are a few rules to writing a Lewis structure. You draw the, you have to know the connectivity. Connectivity is the way that the atoms are bonded. Okay. Now this gives you the connectivity. This shows what? Carbon is bonded to oxygen, right? And all this is this. Then whereas these 3 hydrogens are now? Right here. This is a condensed formula. It shows the structure. The molecular formula is like CH4O, right? That one doesn't, chemical formula or molecular formula don't show the structure, but this one. But this is not a Lewis structure. Lewis structure has to follow certain rules. The atom has to have a duet for hydrogen, 2 electrons around it, like this. Or, for example, water molecule, you need to have duet for hydrogen and octet for oxygen, right? Okay, except hydrogen and helium, others need to have an octet. So this one is okay, octet is there, duet, because 1 electron. This don't have a octet, right? If you count the total number of electrons here, valence electrons, this is 4, 3, plus 6, plus 1, right? So that adds up to 14 electron pairs, right? That means divided by 2 is 7 pairs, 14 electrons, 7 pairs, okay. 1, 2, 3, 4, 5, 6. You have to have all the valence electrons in it, right? Okay. When you look at that, 1, 2, 3, 4, 5, 6, 7. Doesn't it look like it's the correct one, right? 7. And the other bonding, carbon need to have 4 bonds, oxygen need to have 2 bonds. If that one is right? No, why not? Why not this one is? Carbon has 7 electron pairs, right? Here. This one is that one here. How about this one? The same, right? Okay. All right. And also this one, yeah? Okay. All right. This is kind of a review of material, all right, from 120. The other question is something to do with Lewis structures. This is kind of a CH3, COOH, acetic acid, okay? If you look at this one, you go through this. This looks okay here. This looks okay. Carbon has that. All right, then this is here, there's a problem, and this looks okay. All right, now you have a problem here. What is the problem? Here. Did you see that? Why is negative and positive? This electron pair is given here and given there, all right? Normally it happens, okay? It happens in chemical reaction. Electron pairs are pushed up. But in a normal structure, this is not right, okay? Charge don't distribute like that, all right? Unless that's, this breaks off, then it becomes acetate ion. But this is the right Lewis structure. How many of you got that one? Okay. All right, circle the most bond in the following molecules. Polar bond. This is still the review from 120. Okay. How do you know a bond is polar? How many of you remember in your 120 chemistry a word called electronegativity? There's a table in one of the chapters, previous chapters. Fluorine is 4. Electronegativity is 4. That is defined as, electronegativity is defined as the attraction of atom in a molecule to bonding electron pairs, right? Bonding electron pairs. For example, if you have HF, this is the bonding electron pair. Attraction of atom to the bonding electron pair. Therefore, this will be a polarity develops because it's 4. Electronegativity is hydrogen is 2.1, fluorine is 4. I remember this. Carbon is 2.5. I forgot the rest of it. At least carbon is 22.5. Okay, so we have to know polar bonds when the polar bond is formed. So a polar bond is formed when you have a bond between 2 different atoms, right? Oxygen is not 2 different atoms.